Today I'm going to show you how to solve chi-square by me. So chi-square equation. So the chi-square equation is x squared equals to sigma parentheses o minus e parentheses squared over e. So you might be wondering, what are these letters? So O equals to the frequencies observed, so it's like the data that already happened and you already got it. And then E, the frequencies expected, it's like the data that you expect to happen. And then sigma is just the sum of. Okay, so what you also need to know is the degrees of freedom. So these are just a couple of them. So the degree of freedom of 1, and then the critical value of 0.05 is 3.8 for 1. For 2, for the degree of freedom of 2, it's 5.991. And then the degree of freedom of 3, 7.815. And then etc, etc. So also what you need to know is the null hypothesis. So the null hypothesis is the hypothesis that there is no significant difference between specified populations, any observed difference being due to sampling or experimental error. So these are 3 things you have to know about chi-square also. Number 1, it must have 2 outcomes. Number 2, use 0.05 critical value. And 3, you must have 30 or more data to apply chi-square. So here's an example. Say I flip a coin 10 times. Get your expected and observed results. Subtract the amount of outcomes by 1. So this is step 1. So there are 2 outcomes which are heads and tails. So you can write that down. Heads, tails. Expected and observed. Okay, so there are 2 outcomes, heads or tails. So what you want to do is make a data table, heads, tails, expected, and observed. So what I expect to happen when I flip 10 coins is get 5 and 5, because it's 50-50% of chance of getting heads or tails. So I'm going to put 5 and 5. So flip this one, we get heads. So let's go ahead and write down these observed results, heads and tails. So 1 heads, 1 tails, looks like that is tails. Whoops. Another tails. Another tails. Another tails. Okay, another tails. So we got, that's 7, so 3 more coin flips. Heads, tails, and that is 1 more. Okay, heads. Alright, so let's take out these coins out of the way, and let's get to the next step. Alright, so the next thing you want to do is, since you already flipped your coins, so the observed results were heads 3 times, and tails, let's see, 1, 2, 3, 4, 5, 6, 7 times. Alright, so now for step 2, you want to apply the chi-square equation. So it is O minus E squared, I didn't really have to put those parentheses, but whatever, over E. Alright, so we have to apply both of these to heads and tails. So heads we'll put on this side, let's see, heads we'll put on this side, and then tails we'll put on this side. Damn it. Okay. O is observed, O minus E, so that's going to be O minus E, so that's 3 minus 5 squared over E. So E is 5. And then for tails, O minus E, 7 minus 5 squared over E is 5. Okay. So now what you want to do is solve both sides, and then after you do that, we'll get to the next step. So 3 minus 5, that's negative 2 squared over 5. That's 4 over 5. And then 7 minus 5, that's 2 squared 5. That's also 4 over 5. Oh yeah, one thing I forgot to mention was, since you have two outcomes, you want to subtract that by 1. So 2 minus 1 equals 1. And that way you know what degree of freedom you use. So it's going to be the first degree of freedom. Okay, since it's the first degree of freedom and we're using the critical value of 0.05, we just want to write that down so we know. So first degree of freedom, and it is 3.841. Alright, so step 3, you want to add these two things together, 4 over 5 and 4 over 5. So 4 over 5 plus 4 over 5 is going to equal 8 over 5. After that, 8 over 5 in decimal format is 1.6, and the critical value is 3.841. So step 4. You want to accept or reject your null hypothesis. So if the value, which is 1.6, if that is greater than 3.841, then you reject your null hypothesis. If it is less than 3.841, then you accept your null hypothesis. So it is less than this, so we have to accept our null hypothesis.